continue here with question 4. We're given a histogram. Determine whether the approximate shape of the distribution of the histogram is symmetric, uniform, skewed left, skewed right, or none of these. Well, you look at this, it's certainly not symmetric. What's symmetric is going to be, that bell-shaped thing. Uniform is going to be all straight. Skewed left or skewed right. So we can kind of see there is a skew. Remember, the skew is caused by outliers. And so the lower level over here, this is skewed to the left. This is causing the skew. And so we label it as a left skewed. A right skewed would have been basically the flip of this, right? You do a mirror image. A right skewed is going to be big on the left and small on the right. So over here is a right skewed. And again, highlighting the skew is caused by outliers, so those are the low-lying things over there. Blue. So we could just circle this. It is, what did I say, left skewed? It's going to be D. Now we get to do a calculation on here. We're given a bunch of numbers. The numbers of home runs that Barry Bonds hit in the first 18 years of his Major League Baseball career are listed below. Find the mean and median number of home runs. Round the mean to the nearest whole number, which measure of the central tendency, the mean or the median, best represents the data, and then explain your reasoning. Again, you'll get this right or wrong, not necessarily depending upon which one you choose, but how you explain it. Okay, so what we would do, we're going to need a calculator on this one. So let's let me go ahead and pull one up. And apologize for not having it up and ready at the start. Let me, here it is. It's coming. There it is. Okay, so I'll bring it down to this window. Still remembers what we did last time. So remember on these, let's see if I can. However you want. So we want to enter these numbers over here into the stat. So we go to stat, edit. We're going to clear out list 1. Incidentally, maybe you want to do that before you start your exam. Just have it all cleared, save you some time. And now we got to make sure we enter all of these. And as we enter them, we will also get sort of familiar with our values. 25, 24, 19, 33, 25, 34, 46, 37, 33, 42, 40, 37, 34, 49. Whoa, 73. See, that kind of scared me a bit. That's a big one. Maybe like an outlier. It's big. It's a lot bigger than all the others. I mean, it's like twice the size, right? Almost twice the size as most of the other ones. Certainly more than twice in some, but so more than twice. Anyway, now we want to calculate, so we go to stat. Should have been more careful and checked everything. We're going to do one variable statistics. It's up here. Now the default is L1. I'm going to put that in there anyway, just as a reminder that you can always choose which list you're going to use. We hit it. The mean up here is And the mean for the sample and the population is always the same because it's the same calculation, 36.6. They didn't tell us how to round it, but oh yeah, they said round it to the nearest whole number. So that would be 37. Just so, yeah, so maybe over here. So the mean would be 37. And then the median would be, well, we have to go down a little bit here, right? Come down, the median's 35.5, but they say round it, right? So we 36. Round the, oh, mean to the nearest whole number. Okay, well, they didn't say to do it for the median. Yeah, you're right. I know I heard some of you say that. So the median can stay at 35.5 because really you shouldn't round the median. The median is the median, right? Now, which one's better? Yeah, they're pretty close, right? 36, 37. But I would go, one thing I would do is say, well, that looks like an outlier to me. I mean, yeah, it looks like it, but it is. You could do it with, one way we could do this is with the standard deviation. Now, which one do we use? Is this a population? Well, if this is all, well, it's the first 18 years. I don't know how long you was there. So probably using it as a sample would be best. So if you take the mean divided by the standard deviation using the sample standard deviation, 13.2, let's see what we get. And again, it's sufficient to say a sufficient answer would be use median because of outlier. And when you mention an outlier, it's good to mention which data value you're talking about. I'd accept that. I just want to show you, okay, so if we take 37 is what we rounded it to, right? And we divide it by this, what was a standard deviation? Wait, no. What am I doing here? Let's go back. I forgot what I was doing. So one way to look at this, oh, it's going to be a mess. Let's do it again. And again, I could just do that. So it's going to take this plus 2 standard deviations, right? And that means it's an extreme value. That's 26. We could kind of do this in our heads. 26 plus 36 is going to be 50, 72. This is 73, so that's more than 2 standard deviations out there. I'd call that an unusual value, right? So if we're using the mean, plus or minus 2 standard deviations is unusual. Could also look at the, let's go to our plots, at the box plot. Let's see if it looks like it. Again, this may be more than you really need to, but hey, let's use all the tools we got. There's our box plot. And then remember, go to zoom number 9. Yeah, that looks like, that's good enough for me. It looks like an outlier. It's out there. Now, you could find this interquartile range, right? That's 25. That's 45. So you subtract those two, 45 minus 25. Not much work here. 45 minus 25. That's going to be 20. We multiply this by 1.5. That's going to be 30, right? It's 20 plus half of 20, so that's going to be 30. And so the higher Q, this is Q3, and this is Q1. We subtracted them. You take Q3 plus 30, you get 75 is what an outlier would be. So it's not quite an outlier, but it's got a skew, okay? So we're going to accept it at that. So, but I could also say, if you did all this or you came to the point, you could say I would use the mean because they are not an outlier. Both answers are correct, but it's in how you explain it. Okay, so the important part is you could not say I will use the mean because of outliers. No, you only use the median if there's an outlier. But this is the important part that will determine whether your answer is correct or not. You said you will use the mean. Let me see, alternate answer. Mean would have to be saying that there are no outliers. Okay, so both would be correct. I'd accept both because technically there's not an outlier. It's just beyond the field if you do the calculation. But visually it looks like it, so I'd accept that as well. And there we go. Okay, let's keep going. A student receives a test scores of 62, 83, and 91. The student's final exam score is 88, and his homework is, or hers, I don't know, 76. Each test is worth 20, so 20%. The final grade, the final exam is 25, and the final grade of the final grade, and the homework grade is 15% of the final grade. What is the student's mean? So this is a weighted mean. So all the exams are the same weight. What we'd want to do is average the test scores. So we'll take 62 plus 83 plus 91, and we'll divide those by 3. So those, because they're all carrying the same weight. Over here, this stuff. What did I say? 62 plus 83 plus 91, enter, divided by 3, 78.666. So that's as if they had just one test here, 78.67. I'll round it like that. And then to get the weighted mean, we take all the scores times their weights. So for the tests, we'll take that. This, can I move this thing down? Sorry. There we go. Move it out of the way. Okay, so we're going to take the I'm going to take the 78 on here. It's not working right. Draw. There we go. So we would take the exam scores, the average of them, the 78.67. We're going to multiply that by each test is worth 20%. Oh, wait. I guess we could do that. Because the percentages should add to 100. We could average it. We should probably get pretty close that way, but technically, and since we're choosing, we get close enough. Really, what you do is 62% times 20%, which is 0.2, 83 points times 20, and 91 times 0.2. This should be the way. I think you'll probably get the same either way if you were to average them and then do this. Um, no, you probably wouldn't get enough because it's anyway. You need enough. Your weightings need to add to 100%. I apologize. I think I told someone the other way because I just looked too quick. Um, and then the final exam was 88, and that is weighted at the final exams are weighted at 25%, so 0.25. And then finally, the homework is 76. Was a score 76, and it has 15% of the weight. We multiply these, and then we add them. So we can just do that step by step. In the calculation window, 62 times 0.2 plus 83 times 0.2 plus 91 times 0.2 plus 88 times 0.25 plus 76 times 0.15. So it's all calculating together. And we get a score of 80.6. Our choices here are up here. 80.6 is exactly what we got. Now, one other thing I want to show you is you could do this as that you see it's actually a weighted mean. What we can do also is under our stats, go to edit, we're going to put in list 1 the scores, and in list 2 we will put the weights. So 62, 83, and this is going to be especially helpful if you have a large number of values in here. We're not too bad, we can do it, but this is 20%, so 0.2, 0.2. These are going to come in as frequencies. I'll show you how that works. And then this one's 0.25. This one's 0.15. And then we're going to go back to stat. We're going to go to calc. I don't know if everyone can do this. Let's see how this works. I think this works. We hit enter. We want to use the first, we want to use L1, the stats there. We're going to put a comma, I believe. And then we want the frequencies to come from list 2. So then we put our list 2 for the frequencies. I believe this will work. Let's test it. Oh yeah, and see, it gives us the mean is 80.6, just like we got the other way. So you can do weighted means in this way with the values in list 1, the weights in list 2. The deal is when you go to do the calculation, you have to tell it, take the data values from list 1, comma, take the frequencies from list 2. There we go. And now you've got weighted means right built into your calculator. Okay, now we're back to this. So we got 0.6, we did all that. There. Find the sample standard deviation. Now this is a key part. This is a sample, not a population. So we're going to get 2 standard deviations whenever we calculate. So let's go ahead and do that. We go back to stat, we go to edit. We want to clear our list, so we go to the title, hit clear enter. Clear enter. And list 1, we're going to put in this data. Clear this out and make sure you get all the data in there. Remember, if you leave off a piece, you're not going to get it correct. If you make up a new number, it's not going to work. If you transpose, it's not going to work. Garbage in, garbage out. That's my dad's famous lesson to me, because he was a programmer, analyst, back in the 60s, or at the beginning of computer stuff. There we go. And this got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Usually good. And we want to calculate, so we're going to go standard stat, 1 variable statistics. Again, I'm going to emphasize I've got my data in L1, And so we get it. Now we got a mean of 25.222. But what we want, we've got two standard deviations, this S little x and sigma little x. The larger number, 17.8, that is your sample standard deviation. So 17.8, that is our answer right there. Notice they also include sort of, D might be tempting because you got 16.7, but I must have made a mistake. No, you didn't. That's for the population, it would be 16.8 if you're only going to use one decimal place. So none of these other answers really match. So hopefully you would know that. But if you were thinking this, why doesn't this 16.78, why isn't that there? That's because that's for the population. So this one is the sample. Now, again, the question could change and ask for a population one. Well, if you want the population standard deviation, then that's that sigma. That's that one. It's going to be the population standard deviation. Okay, very good. Let's go ahead and move on. Number 8, the mean score of a competency test is 79. So there's a mean with a standard deviation of 5. Use the empirical rule to find the percentage of scores between 64 and 94. Assume a bell-shaped curve, of course. It doesn't make any sense without a bell-shaped curve. But so we just do this. 79 is the mean. If we add 5, we get 1 standard deviation. So 79 plus 5 is 84. Add 5 again, we get 89. We're trying to get to 94. Add 5 again. There's our 94. So we had to add it 3 times, so we're out 3 standard deviations. Let's see, going below, let's start subtracting 5. 79 minus 5 is 74. 74 minus 5 is going to give us 69. Minus 5 more gives us 64. 64 to that's negative 3 here to positive 3, and we need to remember there's a 68, 95, 99.7. 3 standard deviations is here. 95% is if it would have been from 2 standard deviations below to 2 above. 68 would have been 1 standard deviation below to 1 above, and 50%, well, that would have been if you were just either below the mean or above the mean. 50% would be half. So but that has nothing, yeah. So it would be like from 0 to 79 or 79 to infinity or something like that. But just to throw you off. Okay. And finally, let's do this last one since we're on this last page. Find the z-score for the value 57 when the mean is 77 and the standard deviation is 9. So for this one, you want to remember that the z-score formula is x minus the mean over the standard deviation. So we've got the mean of 77, standard deviation of 9, and a data value of 57. So we're going to get a negative number. So what I'd like to do, this can't be it. It's positive, right? I know it's going to be negative. So that's 20, negative 20 over 9. It's going to be like 20 goes in. So it's 2 point something. So I better do use the calculator. I was going to see if I was going to get close enough. But I can't tell whether it's going to be negative 2.3 or negative 2.2. But if I come to my calculator, second quit, and I go 20, not minus, while you're at it, why not just 50 minus 77? Make sure you got the answers right. Divided by 9, 222. So it's got to be this one. And yeah. So that's number 9. While we're here, let's. I think the next one's not too bad. So question 10, we'll go ahead and take a look at. Broke it down a little bit. So we've got this. What do we got? We've got a graph, and the midpoints A, B, and C are marked on the histogram without calculating. So notice you're not actually going to do it. Match them with the indicated z-scores. It would be kind of hard to calculate these. I mean, you could kind of probably do it, but what you've got to look at here is this overall shape. It's kind of like the bell shape. It's got some skew to it, right? But where would and we got these three values. The mean, remember, the z-score is 0 is always going to be the mean. So if one of these has a z-score of 0, it's got to be B. The B is the one that's in the middle. Put it there. And then, so if this is the middle, and if this is the mean, B is the mean, then anything that's negative would be down to A to the left. Anything that's positive would be up here. So it's going to be negative. This is going to be positive. So then we just pick off of here. So A must be negative 1.23 and C must be positive 203. 2.03. Okay, so we could kind of match those ones up. And then it asks for which z-scores, if any, would be considered unusual. So which one is the most extreme, the furthest from the mean? So, the mean's the most likely thing to happen, is really what's that's saying, right? The one that's least likely to happen is the one that's further from the mean. So since this is 2.03, C, I would say most unusual would be C. And again, you could, when you do your test, you can answer like this. I could read these and see this, and so I would say, okay, what's the most unusual? C. Maybe do it at 2.03. And if you remember from the lecture, which is okay if you don't, but remember we talked about if you're around the mean and you get 2 standard deviations above or 2 standard deviations below, that everything in this area would be considered usual, and anything outside of this is what we consider unusual. So anything bigger than 2 or less than negative 2. And it did also show if you're 3 or more out, then it's very unusual. So we could go with that, but this will get you enough to get by on this question. Okay? And those are the answers for the practice test. All right, thank you for your patience with me.